Dear participants of the Conference on Sustainable Development, we present to your attention the work titled as Developing of X65 steel coils making at Steckel mill using thermo-mechanical control process. The speaker is Professor Volodymyr Kukhar. The improvement of metallurgical technologies is referred to a modern, urgently needed global trend aimed to the reducing of carbon dioxide emissions, decreasing the impact on climate change, creating the new environmentally friendly metal materials that reduce material consumption and increase the safety of vehicles, engineering structures, pipelines, and other specific infrastructure. The most common method of making fluid-rolled products for large diameter pipes is rolling on a plate reversible mills, as well as continuous rolling mills. A special place is occupied by the production of plate steel for pipe assortment at Steckel rolling mills. Steckel mills are reversible mills with furnace coilers, which allow significantly saving energy costs and reducing the loss of end trimming wastes. The progressiveness of Steckel mills' use lies in the significant manufacture breathing through the use of heat-reversing and insulating furnace coilers, which help to reduce of energy costs, make less the scale formation and carbon dioxide emissions. In Canada, USA, South Korea, China, Italy, this method of production is common. There are three general approaches to rolling product making that are used as inputs to the pipe-making process: normalizing, thermo-mechanical controlled processing, quenching, and tempering. The combination of rolling processes in Steckel mills with TMCP has significant prospects at the point of view of obtaining steels of high and ultra-high stress grades, raising the standards of human safety. Modern sticking mills and processes allow to produce rolled products with controlling the temperature level to obtain the desired set of mechanical properties of the finished rolled product. Functioning mills, by their design, are divided into several types: single stand, double stand, roughing rolling stand, with additional finishing stands. The processes related to the production of rolled products for large diameter pipes of steel grade from X60 to X80 are of significant importance. As a result of literature review and analysis, it was found that a limited number of studies leave open the question of assessing the technical capabilities of existing equipment of Steckel rolling mills related to developing a new assortment. At the same time, conducting research in an industrial environment at Steckel mills is more accurate, albeit more expensive method. A significant toughening of requirements also has applied to API 5L X65 steel compared to the years of commissioning of the Steckel mills at Prysiazhnyi plant, Italy. Thus, the purpose of the work is to develop the production technology of the assortment of hot-rolled coils of steel grade X65 at the Steckel rolling mill of the Prysiazhnyi plant, taking into account the technical features of the existing heating and rolling equipment. The main equipment of the Steckel rolling mill line is a methodical pusher furnace with 6-zone for heating slabs, manufactured by Bendotti Company, which is heated by natural gas with a capacity of 120 tons per hour, mill 3170 for rolling slabs and strip plates for the Steckel rolling mills, which includes reverse duostand with a rolling force up to 25 MN and a stand with vertical rolls, a 7-zone roller furnace for intermediate heating of the strip plate, which is heated by natural gas. The Steckel rolling mill includes a reversible quadra stand 1780 with a rolling force up to 24 MN and the chamber furnace with a natural gas heated drum coilers, located on both sides of the rolling mill 7080. Unit for laminal cooling of the strip after rolling with a length of 41 meters, which allow to cool the material at the speed of up to 40 Celsius degrees per second. Windows for cooling the strip up to 20 mm thick. The scheme of the main technological line for the production of hot-rolled coils at the Ferriera-Valsider plant is shown in a figure 1. The main assortment of the rolling mills is a heavy plate and coiled rolled products for construction purposes, including resistant to atmospheric corrosion, rolled products for shipbuilding and production of parts of mechanical engineering. The assortment produced is determined by the existing technological regulations of operation of all main equipment. That is, high heating temperatures of slabs for rolling, about 1230 Celsius degrees. High temperature of the furnace with intermediate heating of the rolling from 1100 Celsius degrees to 1250 Celsius degrees. High temperature of the furnace coilers about 1070 Celsius degrees. It should be noted that at these temperatures there are a significant reserve of energy-powered parameters. The actual rolling force in roughing and finishing stands in the range of 12 to 14 meganewtons, with a reduction per a pass from 15% to 50% according to the assortment, which makes possible further development of technology and expansion of the assortment. In figure 2, the finishing stand of the Steckel mills 1780 Quattro with furnace coilers, and in figure 3 is the laminar cooling system are shown. The assessment of the plant capacity to master the technology of production of coils of pipe assortment was based on analysis of the technical characteristics of the existing equipment. As a result of the analysis and preliminary calculations of maximum allowable technological loads on the main equipment of the stands, with the help of mathematical modeling complex, insufficient power of the main drive engines of the 3170 mill and the 1780 Steckel rolling mill, at quite high power characteristics of both stands, which doesn't allow to operate them at the full power. Based on the calculation, the following results are obtained. Table 1. As a billet for the production of coils with dimensions 12 mm, 1510 mm, steel-grade X65 was considered the use of the slabs of Azovstal Iron and Steel Works. Current production cross-section 220 mm per 1510 mm. The chemical composition of the slabs is given in Table 2. The heating temperature of slabs for rolling should be about 1170 Celsius degrees. The heated slabs entered the rolling stands of the dual mill 3170. The temperature of the slabs after the water descaling should be about 1130 Celsius degrees. The first stage of the rolling is carried out in the upper part of the austenitic area in the temperature from 1130 Celsius degrees to 1020 Celsius degrees, with a reduction of more than 10% per pass. The last 2 to 4 phases are performed in the area of recrystallization inhibition in the temperature range of 920 to 880 Celsius degrees, with a reduction of 10%. Implementation of the rough rolling into stages promotes the formation of smaller austenitic grains and more dispersed and homogeneous inherited ferrite structure in the finished rolled products. The recommended temperature deformation modes of rolling through the passes in the stand 3170 are given in the Table 3. Rolling in the Steckel stand should be in a temperature of 825 to 835 Celsius degrees, i.e. below the temperature of complete inhibition of austenite recrystallization, and end at a temperature of not less than 810 Celsius degrees. During the implementation of the described temperature strain parameters, during finished rolling, austenitic grains are extracted, the boundaries of which are fixed by niobium, carbon and nitrogen phases released during rolling and will significantly grind the inherited ferrite grain. The recommended temperature deformation mode of rolling on phases in a stand 7080 is given in the Table 4. Changes in temperature and rolling force in the passes in the Steckel stands are shown in the Figure 4. After rolling, the strip is transferred without delay to the laminar cooling unit. The sequence of going through the technological units before laminar cooling should be as follows: furnace coiler before the mill, Steckel rolling mill, laminar cooling. Due to the short distance of the rolling fields, The work of all technological equipment must be synchronized. Cooling of the coils on the accelerated cooling unit should be performed at the speed of 12 to 14 Celsius degrees per second to a temperature of 560 to 580 Celsius degrees. After the accelerated cooling, the strip is rolled into a coil on a finishing coiler. The final slow cooling of the coils is performed at the warehouse during 48 hours. Conclusions. For the conditions of the Steckel rolling mill of the Ferriera-Balsider SPA plant, the assessment of technical capacity and the development of a complex technology were conducted for the first time for the production of coils of steel grade X65 for further production of larger diameter electric welded pipes for oil and gas. The calculations were conducted and the required capacity of the main engines of rolling mills 3170 and 1780 were installed for the first time at the Ferriera-Balsider SPA plant, which will increase the productivity and improve the quality of the process products. In order to improve the quality of the surface of the coils, the use of controlled air cooling of the coils after cooling was proposed for the first time for Steckel rolling mill. Thank you for attention.